Alright, I'm going to explain angle relationships along parallel lines. So this is the diagram that we will be working with, and the important things to know about this diagram is that L and M are parallel to one another, and P is the transversal. So, there are lots of different angle relationships along this diagram that are very helpful to know. So the first one that we're going to be working with is corresponding angles. And so corresponding angles means that both the angles are congruent, and they are on the same side of the transversal. So an example of this is circled in red, so angle 2 and angle 6. So you can imagine these two sliding right into one another if we just moved M to the left a bit or moved L to the right a bit. So there are many examples of this, especially like 3 and 8, angle 3s and 8, measure 5 and 1, measure 4 and 7. So these are all corresponding angles, and they are all congruent to one another. Now, that does not mean that 1 is congruent to 2 and that 4 is congruent to 3. It's just their pairs that are congruent. So alternate interior angles are on different sides of the transversal. They are between parallel lines, and they are both congruent. So, as you can see, circled in blue, angle 2 and angle 7 are a pair of alternate interior angles because they are both on the inside of M and the inside of L, and they're on different sides of the transversal. So another example of this could be angle 1 and angle 8. So the next angle relationship is kind of like alternate interior angles, except for they are alternate exterior angles. So this means that they are on different sides of the transversal once again, but they are outside of the parallel lines, not inside of the parallel lines. So an example of this is circled in green, angle 4 and angle 6. They are congruent. Another example would be angle 3 right here and angle 5 because they're on the outside of the parallel lines and different sides of the transversal. So the next angle relationship is a linear pair, and this is a bit different from all the other angle relationships that we just looked at because they are not congruent. The two angles add up to 180 degrees. And in order to be a linear pair, the angles have to be adjacent to one another. So there are some examples circled in purple, 6 and 5. They're adjacent to each other, so they add up to 180 degrees. Angle 3, angle 2, adjacent to each other, add up to 180 degrees. So on and on, 4 and 3, 4 and 1, 1 and 2, 2 and 3, 7 and 8, 7 and 5, 5 and 6, 6 and 8, and so on. So our problem asks us to find the value of S and T. And we are given 3 angles. So measure of angle 2 is equal to 14s minus 3t. So that's right there. So then the measure of angle 6 is 9s plus 12t, right there. And the measure of angle 3 is 5s plus 6t, right there. So in order to solve this problem, we need to write shorthand equations using angle relationships. So the first relationship that I see between the angles that we are given is that measure of angle 2 and measure of angle 6 are corresponding, meaning that they slide right into one another. This is circled in red. So they are congruent. So our shorthand equation will be measure of angle 2 is equal to measure of angle 6. Then we can plug in what we know about those two angles, which is 14s minus 3t equals 9s plus 12t. So the next angle relationship that we can use is using a linear pair, and I see this between measure of angle 3 and measure of angle 2, circled in purple. They are adjacent to one another, so they will add up to 180 degrees. So here's our shorthand notation. So measure of angle 3 plus measure of angle 2 equals 180 degrees. So then we plug in our number values, so 14s minus 3t plus 5s plus 6t equals 180 degrees. So now we can solve. So we're going to deal with our first equation, and this was using the corresponding angles. So we have 14s minus 3t equals 9s plus 12t. So we need to add 3t to each side of the equation. Therefore, leaving us with 14s equals 9s plus 15t, because 12 plus 3 is 15. So then I'm going to subtract 9s from each side of the equation once again. So that leaves us with 5s equals 15t. Then we can divide by 5 on each side, leaving us with s equals 3t. And that's as far as we can go with this until we start using our next equation so that we can get a different variable to plug into it. So our next equation, using a linear pair, is 14s minus 3t plus 5s plus 6t equals 180. So the first thing that we can do is combine the like terms that we see here. So 5s plus 14s is 19s, and then 6t minus 3t is 3t, and then it just equals 180. So then we can subtract 19 from each side. So now we have 3t equals 180 minus 19s. So now we want to isolate t so that we know what our variable might equal. So we're going to divide by 3 on each side of the equation. So this will leave us with t equals 60 minus 19 over 3s. So now we have our two simplified equations, and what we need to do is substitute them into one another to find the values of s and t. So I'm going to plug in t into this. So we have s equals 3 times 60 minus 19 over 3s. So I'm going to distribute the 3 into the parentheses. So s is equal to 180 minus 19s. So now we can add 19s to both sides of the equation, leaving us with 20s equals 180. We can then divide by 20 on each side to isolate s. This leaves us with s equals 9. So we figured out the value of s. So now to find out the value of t, we can plug in s for 9 in this equation. So now we have that 9 equals 3t. So to isolate t, we can divide by 3 on each side, leaving us with t equals 3. So for our solution, we have that t is equal to 3 and s is equal to 9. So there we go.